Black Hills Information Security, the leaders in penetration testing and active defense. Email consulting@blackhillsinfosec.com to request a quote today. Threat Connect is the industry's most widely adopted threat intelligence platform, built to unite the people, processes, and technologies across your security team, your organization, and your entire ecosystem of partners. Threat Connect's threat intelligence platform enables your team to collaborate, analyze, and make sense of threat data all in one place. Empower your team towards fast and efficient analysis that leads to decisive action. Transform your entire threat detection and response program today. Claim your free account at threatconnect.com/securityweekly. Faraday is an open source collaborative pen test and vulnerability management platform. With real-time dashboards and more than 50 tools, Faraday allows seamless integration with your security workflow, allowing CISOs and pen testers to see in real time the impact and risks uncovered from assessments. Scan your network every day using different tools and get one-click reports, creating a collaborative experience, sharing knowledge, and making pen testing fun again. This is Faraday. Visit faradaysec.com for more information. Welcome back, everyone, to Security Weekly. The fabulous, the lovely Joff Thayer is here to deliver information about black holing your Python. I mean, your Python black hole. I mean, DNS black holing using Python. That's what I meant.
Oh, there you go. Thank you for that lovely introduction, Paul, on black holing my Python.
Yes.
Okay. First of all, just want to get the plug out of the way. I will be teaching Sec 573, Python for Penetration Testers, at SANS Network Security Vegas the week of September the 12th. So please take a look at that.
And that's how many days?
It is a 5-day course at
5 days of you talking about your Python. That's awesome.
5 days of me talking about my Python.
Alrighty.
Exactly. So yeah, please come out and check that out. See if you can register for me talking about my Python.
Come out, giggity. Sorry. Okay, I'm good. Paul. No, I'm good.
So Paul and I had this conversation, as do many people. Not
many. Some people. People in our industry have this conversation.
People in our industry, not just about the Python, but this question comes up often. Why would I write a Python script when I can use Bash, cut, sed, awk, Perl,
grep?
Well, maybe Perl is a bit of a stretch.
No, not Perl. Grep.
Yeah. To do all these wonderful things. And I said, well, why don't we have a little bit of scripting fun to see what we can do? And Paul, if you recall, last week for our regular listeners,
yes,
talked about the most wonderful DNS black holing ideas that he was working on with Bash scripts.
Yeah. So, Joff, I'll set the stage.
Please.
I wrote a crappy little Bash script that basically helped automate DNS black holing of malware and ad domains using my own crappy little Bash script. A listener extended my Bash script, which is just awesome. I love you listeners. It's so great. I need to put a link in the show notes that links to that. He did a fantastic job and extended it and cleaned it up a little bit, which was great. And then at the same time, the developers of Pi-hole, I know that sounds very strange, but it's called Pi-hole, pi-hole.net. They have an elaborate and extensive collection of Bash scripts that do everything for you and automate the whole thing on your Raspberry Pi to do automatic DNS black hole of your malware and ad domains. And they automate the whole thing. In fact, they give you like this one command install script right on the front page of their website. You can do the whole thing automated, but all their thing is open source. I did look through all of their code. It looks really good. I didn't spend a whole bunch of time like reviewing it line by line, but what they've created looks really good, and I wanted to give them a plug. It's a free open source project. You can go look at their code too. It's in a GitHub repository. It's pi-hole.net.
Oh, perfect. Well, shout out to the Pi-hole.
Shut your Pi-hole. That's right.
So it's really good. But anyway, I thought, well, why not? I will go ahead and write a similar script that Paul had written to operate with bind9, which is the ISC bind9, and create configuration and zone files to Blackhole DNS requests based on input data that comes from the various C2, DGA, D-Shield, you name it, the various, malware domains is another one,
Yep.
various publishers of essentially bad domain lists that are out there on the internet.
And I want to explain the underlying problem that we're trying to solve here is that people pay a lot of money for so-called threat intelligence. And we had the Wade Baker from Threat Connect on, right? And we're sponsored by Threat Connect. But a lot of people think that threat intelligence is, well, give me the list of bad IP addresses and bad domain names, right? And we at Security Weekly are like, well, this is all open source. We can do a lot of this ourselves. We don't have to go buy a product to do this. Wade agrees with us, which is fantastic, which is one of the reasons why they're a sponsor. But I wanted to do some of this on our own using just standard scripting with standard open source software to be able to accomplish this.
Yeah, exactly. So I spent, I think, all of 2 hours writing a script which essentially does this. It creates a bind9 configuration file which will list all of the domains that it fetches from a URL and point them to a bind9 Blackhole zone file of which you can resolve all of those domains to any address that you specify when you run the script.
And we've had a lot of interesting conversations about this, Joff, whether 127.0.0.1 is the best one to use, or is it 0.0.0, or is it an internal IP address or domain name that runs a web server that will serve a 0-byte image? So those are like the 3 different methods that we haven't tested them all. In theory, they all work. I don't know which one works best, to be honest with you.
And that third option actually is quite a fascinating and interesting option to me and Paul, and I think the rest of the crew on Security Weekly. And actually, I do have a secondary project, which Paul and I have named TachyonNet, which actually will be listening on all TCP, UDP, and raw sockets and logging data that connects to it. So it'll act a little bit like a honeypot,
which is funny because it's similar to my previous Python project of the HoneyNet, which I wrote in Python, which listens on specific ports and then reports on them because they're ports that shouldn't ever be connected to. So it's kind of interesting that we've come almost full circle with that.
We come full circle, which is kind of cool. But I'm actually really interested in the TachyonNet concept down the road, and I'm going to keep pushing that development out. And Paul and I are going to kind of prototype that together. Which
I have a development server that I'm working on building, Joff, that I can test the code out on because I want to test it out here in the office and at home to see what would happen if we resolved all those names to a specific name and went with the whole port thing and found interesting things. So I think that's a follow-on tech segment to this one.
Yeah, we will definitely look at doing that, especially as that code develops. That's a much more interesting animal and more complicated animal. But let's talk about Python just for a moment. And I will, I guess, go ahead and share a window. I know syntax can be sometimes boring, but so I'm going to share a fabulous shell command window. Look at that. The wonderful dollar symbol, right, that everybody knows and loves. I have this program here called DNSBH.py, which is a Python script that actually does the work for me that I want it to do. And I want to point out a couple of different things in this Python script that are useful. First one is just a simple function to fetch a URL. All this does is it's a Python function to fetch the URL that's passed to it and read the entire content and return that byte content back to the core of the function.
And I see you're using urllib2, which we talked about in depth when Mark Baggett was on the show as well, which I think is hilarious.
Exactly. Now, this is this is probably the simplest, most elementary use of urllib2, which is just to simply read the entire contents of the URL you pass to it and just return that content. Okay. Then I actually have another function here, which I call create zone file. What create zone file does is you pass it in a TTL and an IP address, and it writes out a file which is a bind9 compatible zone file using that TTL and IP address, and it uses the @ symbol that resolves anything that is of that zone name to the IP address that you pass to it. Okay, and I think, Paul, you probably makes sense to you. That's what you were doing similarly with the Bash scripts, except this one's got a little bit of flexibility.
Yeah, okay. I was, in all the scripts that do this, Joff, I noticed they normalize the data coming from all the different sources as well.
Yep,
and also this script is Python 2 only.
Yes, correct. This is a Python 2.7 compatible project. Thank you, Carlos, for adding that.
Good eye, Carlos.
Yeah, I noticed by the libraries and the prints.
Yep.
Yes.
I do have another function here, which is called createNameDconf. And it is named accordingly because its function is to create a bind9 configuration file for all the domains in the data that are passed to the function. So effectively what this does is it splits the content that is passed to it based on the new line character, and then it loops through all that data and matches everything in the data to a regular expression. And the regular expression is an attempt to match a domain name. The regular expression is defined up here. It is a compiled regular expression. Python regular expressions are much like many other languages that do regular expressions where you're looking at POSIX or Perl compatible. Mm-hmm. They're all fairly similar. What this does is it attempts to use the domain name syntax where we're matching lowercase A through Z and 0 through 9. Now, the reason I'm not doing uppercase is you notice here I'm passing the ignore case flag into the regular expression match. So I'm matching lowercase A through Z, 0 through 9, as well as a dash character, and then a plus, meaning one or more characters of that, and then putting the period on the end. And then that particular group, I want to match one or more of those. And so if you get the idea, I'm building out a domain name with that match, okay? And then at the end of the regular expression, I'm matching what effectively is most likely a TLD, as in lowercase A through Z plus. A little bit of a fudge there.
Because the malware in ad domains are not always .com. In fact, a lot of them aren't.
Yeah, exactly. They could be .com, .net, .org, .biz, .ninja,
.deal. There's all kinds. Yeah,
any one of those things. So what this thing does, it then loops through that content that's passed to it. If it sees what looks like a comment character at the beginning of the line, it continues, meaning that it starts that loop again. If it doesn't see a comment character, it tries to match the regular expression. If there is a match, it will then print a line out to the resulting zone file that contains the domain name, the actual directory that you want to put the zone file in, and then the zone file name itself nicely into that configuration, okay? So the way this thing runs is down here. In Python syntax, when you match if __ name equals main, you're actually looking for the fact that this is running not as a module, but the fact that it's running with what's called the global main namespace. So that's what that if test does. It's more apropos, to be honest, when you're actually defining full modules in Python, but generally it's a good practice in scripts to drop this in as a sort of a best practices kind of item. Okay?
Yeah, you can also do it for tests. If you write a module, you can put your tests there, and you can run your module individually.
Exactly. Now, this is not a object-oriented based program, so there's not an actual class-based structure in a module. But Carlos is exactly right. If you were writing a module and you had different classes in this script, then this is a perfect way to test that module, because you can run it as a script, and this name will be main when you run it as a script. But this name variable will actually be something other than main, i.e. the namespace of the module, if it's running as a module. So that's one of the reasons we use this as a best practice.
Carlos, I thought you were a PowerShell and Ruby guy. And
no, in fact, DNS Recon is around 4,000 lines of Python.
I am impressed with your multilingual programming language skills, Carlos.
Well,
Carlos is a multilingual kind of
I
guy.
do a lot of stuff in Bash. A
Wow,
lot
that's awesome.
Python.
That's awesome.
Ruby, uh, PowerShell, C Sharp.
Nicely done, Carlos.
Very good, very good. So you guys can just take my tech segment from here. No, I'm just kidding. So then we're using the argument parser in Python after this in the main section of the program here. The argument parser is what allows us to, it uses a inbuilt Python module that allows us to parse the arguments on the command line. A very nice way of essentially using code that's there and not having to build it yourself, so that when you run the program, you can have these various command line arguments that you pass in. What I'm passing in here is a non-optional or required argument called URL. The URL, the help, is the malware domain list URL that you want the script to read. Next, I'm passing in an optional argument, that passes the zone file that you want to create. This defaults to db.blackhole. And then I'm passing a second argument here, which is again an optional argument, which is the named configuration file that you want to create. By default, that defaults to named.bh.conf, bh meaning black hole in short. And then the third argument that I'm passing in here is the bind directory argument that you want to place into the configuration file. This allows you to place something like, I don't know, /etc/bind in front of the actual individual zone file statements inside that configuration file in case your zone file data is in a different directory. That defaults to null to just place things in the current directory. And finally, we have two arguments here that I'm passing in. One is the IP address that you want that zone file to resolve to. That is also going to default to 127.0.0.1 per our discussion earlier where we talked about which IP to resolve to. And then I also complement that with the TTL of the zone file to create. And I'm defaulting that to 3,600 seconds. You can certainly make that shorter or longer depending on what your preference is. That TTL is a DNS TTL that you're going to place inside that zone file. That's pretty much the nuts and bolts. After that, there's some IP address validation code here, which uses a regular expression module to validate an IP address. If anybody's tried to validate an IP address with regular expressions, it is not as trivial as you might think.
I would just Google that is what I would do.
Yeah, Google that. I will show you briefly, but here is the regular expression for 1 octet of the IP address.
I use a library called netaddr that
I've used that before.
Simplifies it for me a lot. I can tell it, check if it is IPv4, if it is IPv6, is it public, is it local. It simplifies all of that, and it's a very nice library that works with Python 2 and 3.
Oh, that's a great suggestion. And Carlos is exactly right. Writing regular expressions for IP addresses, it might seem intuitively simple, because if you think about it, it's dot quadded and they're just integers. It is
especially
not,
when you add IPv6.
Yes.
And when you get to v6, it's even worse. But it does. This one does work. This is totally Google code, I have to admit, but I dropped it in there really quick this morning just so I could make sure that we were validating IP addresses properly.
Now, Geoff, I didn't see, do you handle duplicates in it?
I do not handle duplicates right now. Mind you, Carlos, this is a 2-hour script. I'm done. So let's just leave it at that. Let me show you how it runs. So I've got a file here, domains.txt, which is just a handful of different malware domain feeds that I Googled up. This file is something I'm going to use just to show you how to run it. If we run it with the defaults and we pass it malwaredomains.com and domains.txt, you'll see that it creates the domains file, it creates the db.blackhole file with the appropriate parameters, and then it writes this named.bh.conf file. It fetches the URL all in one hit. So fetches the URL, creates the zone file, creates the named.bh.conf. If you look at the named.bh.conf, it has some auto-generated text at the top, drops in the time and date stamp in UTC, because why else would you use any other time zone? And then it puts in a zone statement for each domain that it fetched and matched in the regular expression as part of the code, pointing the actual zone definition to the file db.blackhole, which is that default zone file for bind9 format.
Now, Joff, two things. One, Carlos's point is extremely important because, as I mentioned in the previous segment, you're going to get a lot of overlap in those lists. And I found overlap between ad domains and malware domains, which I thought was very fascinating. The other thing is it's going to take longer to start your DNS server, to start bind the actual service, because it has to read in all of that information. I found like I restarted or would start my bind server, and then I'd start doing lookups, and it would tell me it failed. And then I'd try again like 15 seconds later, and it completed. I'm like, oh, like it actually takes almost 30 seconds. I mean, I'm running on a Raspberry Pi. If you're running on larger hardware, it's going to take less time, obviously. But it takes a long time to load all those zones up to start the server.
So that's a very good point. Notice here, there's 27,508 lines in the named.conf. That represents 27,000 plus domains. So you're absolutely right. DNS is going to take longer to start up with this configuration, and that could be a concern for folks.
Well, yeah, because you think like, oh my God, it's not working, and it's no, just give it time, and then it'll work.
So this, like I said, this is a bit of a one and done script. Deduplication can certainly go into it, and is not difficult to do using Python dictionaries. And that's probably going to be the modification once we're done. If you run it with the help command, you can see that you can specify the different things here to modify the behavior. We can actually use -b and call it db.blackhole2 and do -n and call it named.conf2 or something like that. Specify the IP as like 10.1.1.1. And then run it with that same URL. And then if you look at that db.blackhole2, you'll see that the address down here is now
Gotcha.
10.1.1.
Nice. I like that flexibility, especially for the next technical segment that we're going to run on this subject. So
exactly right. Yeah. The other thing that's interesting here is the serial number of the zone. One of the enhancements that I will make to this script is that for a specific zone file, it will eventually track the serial number.
Yeah, and auto-increment it.
And auto-increment it instead of just writing a 1 there, because that's important for DNS, because DNS won't actually consider the cache data to be old unless that serial number is.
Yeah, because I think now I'm just running both my DNS servers to pull down the script independently. I'm not running one as a secondary zone.
Right.
Just in case
I would run it as a secondary, to be honest.
I don't know. I did both just in case I lost one DNS server. I didn't have to. I would still get updates, but I don't know. That's like splitting hairs. You know what I mean? So
yeah. So one of the nice things about this script is because it uses a regular expression, it almost doesn't matter where you're getting the data from. If it matches a domain name, and
that's
maybe
nice.
Some false positives, but if it matches a domain name, it's going to create it.
That's awesome.
Yeah.
So that's pretty slick, I thought, anyway.
Oh yeah, it is. I would also recommend probably adding DNS Python library. It allows you to grab that zone file and do a sanity check on it. It has it has a series of classes where you can import the zone file. It will check it, and then it has a method that checks its sanity to make sure that it's properly formatted and everything.
Yeah, that's an interesting comment, Carlos, because I was actually considering just using the old named-checkconf program, which is part of bind9, and putting it in as a shell callout or a popen in the case of Python to check that.
I like Carlos's suggestion better to use the Python library.
No, in fact, I have a challenge for our listeners. How about grabbing the ideas that Joff just brought and everything, and probably integrating it, let's say, with Open Thread Exchange and using their taxi library, connect to it, download all of that sticks data, and then parse that data out of sticks, since that is already threat intelligence format data already available for malware and TTPs of state actors and everything. And it actually has entries in it in the XML for IP addresses, entries for DNS host name, URLs, and all of that stuff. And you can actually just grab that data, subscribe to it every 2-3 hours or every 24 hours, go in, do my RESTful connection, or actually use their DNS Python library, download an update of that threat intelligence, parse all of the DNS host names, and create those on a cron job.
And I want to say either I found this in my Google searching or a listener sent it to us, and I'm leaning towards a listener sent it to us. There is a project that does this for Microsoft's DNS server, and I want to say it's written in PowerShell. If that doesn't, that does exist, right?
It doesn't go to the Open Thread Exchange.
No, but
it's part of, I think, SANS 503. I think, class.
Yeah.
It is part of that material. He has a library for Windows 2008 R2. It works there. Now with the latest versions of 2012 R2, and 2016 that comes out in September, you actually have already a commandlet that is called add-DNS-A record, and you just give it the parameters, and it will add the record over to whatever zone file you want in Windows.
Yeah, no, that's an interesting point, because Bind9 also has a dynamic way that you can add records to a running configuration. So there is live options that you can do instead of static zone files. So there's all kinds of interesting variations on this you can pursue. That don't have to be, static zone file based. It just twigged my memory on that particular.
And in fact, I love DNS for one specific reason, and it is that it is one of the least leverage infrastructure services in a network that you can do security on.
Yep. I agree.
I've talked with so many incident responders, and one of my checkboxes to see if it's good or bad is when they tell me, oh no, one of the things I check initially on the first day is DNS logs. And when they say I go to the DNS logs, I go like, this guy knows his shit.
Right.
Because he goes in, he parses those logs and just starts comparing that data. I actually had friends that written scripts in Go and in PowerShell that just connects to Open Thread Exchange and pull that data of known ones, and they create their own little databases that parses Microsoft and Bind log files and go through those when they do incident response to check if they see anything that flags up as something of a known actor when they're doing incident response.
I think this is an incredibly important topic and an important aspect to add to your defense, because it's relatively cheap to implement. In other words, it's free. The software you can write yourself or download libraries or other people's projects and implement those in your network. Yes, it takes a little bit of work, but I think it's a very low cost and very high yield defensive activity that you can put in your network.
And another one that I think, Joff, how hard would it be probably to add to this some type of logic? I don't know if I not probably on generating the file, but let's say looking at logs, and if the host is of X size, flag that and automatically create, add a part that looks at logs, and if a host name is of X size, add a black hole to it.
I don't think that would be difficult at all. I think
that.
Once you get into that space, though, you probably want to use the APIs within Bind9 and be able to dynamically add that to a running Bind9 server rather than try to add it statically, because the RNDC reload or the signal to reload a Bind9 process is a little expensive.
Yeah.
And I think it'd be better if you can insert that data live into a running server. And I think it's certainly possible. It's just a more
because I see it for those that use TXT records to tunnel their connections to the outside. You start looking at the entropy of those names, and if all of a sudden they have a very high entropy, you know that somebody is doing something nefarious in your network, and they're using DNS to go outside of your network, and you start flagging those and blackholing those, and you start cutting all of those command and control channels for an attacker.
Awesome. That's a great idea. I want to, Joff, I wanted to ask you, where can people download your code?
So I just put it up on the screen. Is my window still shared?
Yes.
Yes.
So if you go to Bitbucket, you can get just the rudimentary code. Like I said, this was a quick one and done, but I'll probably develop it out a little bit more to give it a little bit of deduplication. I welcome, any contributions that people would like to make, or just take it, do whatever you want with it. I think it's an interesting idea that even in its current form is perfectly useful in a lot of networks, and I welcome you to take it, play with it, make suggestions, and talk to us about
that
it.
URL is bitbucket.org/JS Thayer, THYER /DNSBH.
Yep, absolutely.
Again, that's bitbucket.org, JS Thayer /DNSBH. Go there, get Joff's code, and look for follow-on technical segments. Thank you very much, Joff. Thank you very much, Carlos, for your input on that, as you've written a lot of code in this space as well. Fantastic suggestions for future features. With that, we're going to take a short break, come back with our security news for this week. Stay tuned.